electromagnet. By the end of this lesson, you should be able to state what an electromagnet is, draw the magnetic field pattern due to a current in a straight wire, coil, solenoid. The Earth has its own magnetic field. The Earth's northern magnetic pole is actually a south pole, and the southern magnetic pole is the north pole. That is why the north-seeking pole of a compass needle points north. It is attracted towards the Earth's south magnetic pole. The permanent magnet has a magnetic field inside and outside the magnet. The magnetic field lines never intersect. The field lines form closed loops. The field in 3D is like a system of concentric misshapen donuts. All electrically charged particles are surrounded by electric fields. What you have just seen are examples of naturally existing magnetic fields. Can we create magnetic fields? Can we change the strength of magnetic fields? The most common elevator brake is made up of a compressive spring assembly, brake shoes with linings, and a solenoid assembly or an electromagnet. When the solenoid is not energized, the spring forces the brake shoes to grip the brake drum and induce a braking torque. The magnet can exert a horizontal force for the brake release. This can be done directly on one of the operating arms or through a linkage system. In either case, the result is the same. When the brake is pulled away from the shaft, the motion of the elevator is resumed. Do you know what an electromagnet is and how does it work? An electromagnet is a type of magnet in which the magnetic field is produced by a flow of electric current. The magnetic field disappears when the current ceases. How do we make an electromagnet? The picture shows the apparatus used to make an electromagnet. Click on the switch to close the circuit. Bring the container of paper clips near the iron nail. What happens to the paper clips? The paper clips are attracted to the iron nail. What happens to the iron nail when there is a current flow through the solenoid? When there is a current flow through the solenoid, the iron nail becomes a magnet or is said to be magnetized. Click on the switch to switch off the current in the circuit. What happens to the paper clips now? The paper clips drop back into the container. What happens to the iron nail when there is no current flowing through the solenoid? When there is no current flowing through the solenoid, the magnetic effect of the iron nail disappears, or the iron nail is demagnetized. An electromagnet is a temporary magnet and is produced only when there is a flow of electric current through a solenoid wrapped around an iron core. A retort stand, a copper wire, batteries, and a cardboard has been set up. A bottle of iron filings and 4 plotting compasses are also available. Click on the bottle of iron filings to pour the iron filings onto the cardboard. Click on the switch to allow the current to flow. The cardboard is then tapped gently. What happens to the iron filings? The iron filings form concentric circles with wire as the center. This is the magnetic field pattern due to current in a straight wire. Now click on each plotting compass and drag it to the different positions on the cardboard. What can you say about the direction of the magnetic field lines due to current in a straight wire? The plotting compasses show that the magnetic field pattern due to current in the straight wire is in the anti-clockwise direction. At any point on the straight wire carrying current, the magnetic field pattern is in the form of concentric circles with the wire as the center. Hold out your right hand with the thumb pointing upwards. Your thumb shows the direction of current flow in the conductor. What can you say about the direction of the curling fingers and the direction of the magnetic field as traced by the plotting compasses? The direction of the curling fingers is the same as the direction of the magnetic field as traced by the plotting compasses. This is the right-hand current rule, or commonly known as the right-hand grip rule. Viewed from the top, the magnetic field pattern due to current in a straight wire is in the anti-clockwise direction. A circle with a dot in the middle indicates the direction of the current to be coming out of the screen. What can you say about the magnetic field pattern if the direction of the current flow is reversed? Verify this using the right-hand grip rule or right-hand current rule. A circle with a cross in the middle indicates the direction of current going into the screen. When the direction of current is going into the screen, the magnetic field pattern is in the clockwise direction. The magnetic field pattern due to a current in a straight wire is in the form of concentric circles. The direction of the magnetic field lines can be determined by using plotting compasses or the right-hand grip rule, which is also known as the right-hand current rule. A retort stand, a circular copper coil, batteries, and a cardboard has been set up. A bottle of iron filings and 8 plotting compasses are also available. Click on the bottle of iron filings to pour the iron filings onto the cardboard. Click on the switch to allow the current to flow. The cardboard is then tapped gently. What happens to the iron filings? The iron filings form concentric circles around each arm of the coil with wire as the center. The picture shows the magnetic field pattern due to current in a circular coil. Drag and drop each compass anywhere close to the coil to determine the direction of the magnetic field lines. What can you say about direction of the magnetic field? The plotting compasses show the magnetic field pattern due to current in a circular coil. View from the top. The magnetic field line at the center is in the form of a straight line. The lines in the coil between the two wires are more closely spaced than the outside. The field lines around the two wires are in opposite directions. How can you use the right-hand grip rule to determine the direction of the magnetic field pattern due to a current in a circular coil? What is the direction of the magnetic field lines? The direction of the magnetic field lines is anti-clockwise. What is the direction of the magnetic field lines? The direction of the magnetic field lines is clockwise. What will happen if these two wires are brought closer together? When the two wires are brought closer, the field lines interact and produce new magnetic field line patterns as shown. A retort stand, a solenoid, batteries, a switch, and a cardboard has been set up. A bottle of iron filings and 4 plotting compasses are also available. Click on the bottle of iron filings to pour the iron filings onto the cardboard. Click on the switch to allow the current to flow. The cardboard is then tapped gently. What happens to the iron filings? The iron filings form a magnetic field pattern similar to that of a magnet bar. Outside the solenoid, the field lines loop around from one end to the other. The field lines in the center of the solenoid are close and evenly spaced, resulting in a strong uniform field. Outside the solenoid, the field lines are uneven and more widely spaced. Drag and drop each compass to determine the direction of the magnetic field closer to the solenoid. What can you say about the direction of the magnetic field? One end of the solenoid acts as a north pole, which repels the north pole of the compass, whereas the other end acts as a south pole, which attracts the north pole of the compass. The field lines move out from the north pole and re-enter the loop at the south pole. Is there any other way to determine the poles of a solenoid? The direction of the magnetic field in a solenoid can also be determined by using the right-hand grip rule or right-hand solenoid rule. Grip the coils with your right hand so that your fingers point in the direction of the current flow through the coils. Your thumb then points in the direction of the field inside the coil. The end of the solenoid where the field lines emerge is called the north pole. The other end where the field lines enter is the south pole. The polarity of a solenoid can also be determined by using the solenoid rule. Look at the coil at the end of the solenoid. If the direction of the current flow is anti-clockwise, then that end is the north pole. But if the direction of the current flow is clockwise, then that end is the south pole. Click on the bottle of iron filings to sprinkle iron filings on the cardboard. Click and drag the slider of the rheostat to vary the current flow in the coil. What happens to the magnetic field formed on the cardboard? The magnetic lines are closer when the current is bigger. This shows that the strength of the electromagnetic field increases with current. As indicated by the direction of the needles in the compasses, the direction of the magnetic field remains the same. Click on the Select button to choose the number of turns of the coil. Click on the switch to switch on the circuit. Does anything happen to the magnetic field formed by the coil? The magnetic lines are closer when the number of turns of the coil increases. The strength of the electromagnetic field increases with the number of turns of the coil.